Introduction, area between two curves. What is integration? Integration is the reverse of differentiation. Okay. This is example x power of n dx. To integrate this equation, increase its power by 1. That means n plus 1. And then divide by the power n plus 1. That means the equation x power of n plus 1 must be divided by its power n plus 1. I give you the second example, x cubed plus 4x squared plus 3 dx. To integrate this equation, the power of 3 plus 1 will be 4 and divide the power of 4. For 4x squared, the power of 2 plus 1 will be 3 and then divide by the power of 3. For 3, it means 3x power of 0. So 0 plus 1 will be 1 and then 3x divided by 1 will be 3x. Determining the area between x equal fy and x equal gy. This is the formula to find the area of the shaded region defined with respect to y. The lower limit and the upper limit must take at the y-axis. So this is the lower limit and this is the upper limit. How to find the right and the left? If you put a rectangle at here, you can see x equal fy is at the right side and x equal gy is at the left side. So it will be fy minus gy. So if we use dy, it means the upper limit and the lower limit must take at the y-axis and the equation must be y.
Introduction, area between two curves. Why we use integration? We use integration to determine the area between y equal to fx and y equal to gx. We have two functions here, y equal to fx and y equal to gx. We want to find a shaded region here, area in the shaded region here. So the formula is area integral a until b top minus bottom dx. The starting point is a until b. A is the lower limit and b is the upper limit. There is always lower limit until upper limit. So how we want to find the top function and bottom function? We can draw a rectangle in the shaded region here. So we draw a rectangle here, and this is the top and this is the bottom. So the top is at the straight line, which is y equal to fx. So top equal to fx and bottom in the quadratic function, which is gx. dx. Why we use dx? Because we have to define with respect to x.
Okay guys, let's move on to the example of question. Okay, the question is the region R in figure below is bounded by the curve x equal to y squared minus 4y plus 2 and the line x equal to y minus 2. Okay, for question A, find the coordinate of A and B. Okay, if you guys can see at the diagram have two equation of x. Okay, so we need to identify which one equation 1 and which one equation 2. So after we identified the number of equation, means equation 1, which one equation 1 and which one equation 2, we need substitute equation 2 into equation 1. Okay, so we will get this equation. Okay, and then we solve this. Okay, and we get the value of y. Okay, 1 and 4, y equal to 1 and y equal to 4. So after we get the value of y, we need to substitute into this equation to get the value of x. Okay, so in step 2, okay, if y equal to 4, we get x equal to 2. Okay, and if y equal to 1, and we get x equal to -1. So, okay, in this section, okay, we need to identify which one for coordinate A and which one for coordinate B. So, we look at the value of x, okay? So, we get one negative and one positive. So, we look at the diagram, okay? Which one for value of x will position the value of negative. So here, this is negative b, and this is for the region of negative value of x, okay? So of course, this is for coordinate b, and this is for coordinate a. So a coordinate is 2, 4, and b coordinate is -1, 1. So let's move on to question B.
Question B. Find the area of the shaded region R. This is the formula to find the area of the shaded region with respect to y. The upper limit and the lower limit must be taken at the y-axis. So, you can find the upper limit and the lower limit at coordinate A and the coordinate B. Now, how to find the right equation and the left equation? If you can see here, this is the right side and this is the left side. The right will be x equal y minus 2 and left will be x equal y squared minus 4y plus 2. Then, we can put all the information here into the formula. It will be the lower limit is 1 and the upper limit is 4. And the right minus left will be y minus 2 minus bracket y squared minus 4y plus 2 dy. Before you integrate this equation, you must expand it first. So the answer will be 5y minus y squared minus 4 dy. And then you can integrate this equation. It will be 5y squared over 2 minus y cubed over 3 minus 4y. To get the answer, you must sub the upper limit and the lower limit into y. And then you can use your calculator to find the answer, and you will get 9 over 2 unit square.
The question is, the region R in figure below is bounded by the curve y equal x squared plus 2 and the line x plus y equal 4, which is this equation and this equation. So for A, we need to find the coordinates of A and B. How to find the coordinates of A and B? First, we need to identify which one is the first equation and which one is the second equation. From this, we assume that y equal x squared plus 2 is the first equation and x plus y equal 4 is the second equation. Next, we need to substitute second equation into the first equation, which we will get 4 minus x equal x squared plus 2, and we can solve it using calculator, and we will get x equal 1, x equal -2. Next, we substitute the answer x equal 1 and x equal -2 into the equation. So when x equal 1, we will get y equal 1 squared plus 3 equal 3, and the coordinate will be b, 1, 3. When x equal -2, we need to substitute -2 inside the second equation, which it will be y equal 4 minus -2, y equals 6. So the coordinate will be -2 and 6. How to determine which one is A and which one is B? So we need to follow and look at the figure. So from this, we know that A have x value, negative value for x. So we know that -2 and 6 is the coordinate for A. So this is how to find the coordinates A and B. That's all for the solution for A question. Question B. Find the area of the shaded region R. We want to find the area in the shaded region. So the formula is area equal to integrate A until B top minus bottom dx. Where we want to find the function top and bottom is we can draw a rectangle here. So this is at the top and this is the bottom. So the top is at the function in the straight line x plus y equal to 4 and bottom in the curve here which is y equal to x squared plus 2. And then we use the formula integral -2 until 1 where we get this value is in the question A. So the starting point is start from this -2 and 1. So how we get the value -2 and 1? And then the top function is 4 minus x. How we get 4 minus x? In here. Because we have to change into the terms of y. So y equal to 4 minus x. And then minus bottom. Bottom function is here in the curve. Y equal to x squared plus 2. So x squared plus 2 dx. And then we simplify this function and we get 2 minus x squared dx. And then we integrate this function, you get 2x minus x squared over 2 minus x cubed over 3. -2 until 1. And then you substitute -2 and 1 into x. So the final solution is you get 9 over 2 unit square. Why you use square? Because we want to find the area.
We can conclude that the method we use to solve this question are accepted. For both questions, the answer for the area of the shaded region are 9 over 2 units square. We can use this method to solve other problems that related to this topic. But first, it is important for us to know how to determine the top function and the bottom function and to determine the upper limits and the lower limits.